Hello, today we're going to go over the difference quotient. You need to be familiar with how to take the composition of a function, like taking the f of g of x. If you don't, watch my video on that and then come back and watch this one. But otherwise, let's get started. So this is the difference quotient. It says the f of x plus h minus the f of x divided by h. And this has some very important implications in calculus. So you'll see this probably one of the first lessons you take in calculus will be using the difference quotient to do something, okay? What it is and as far as how it's applied, you don't have to worry about it right now. Right now in my class, what I want you to be able to do is to take some function that is the f of x, and so in this case it's 2x plus 6, and then I want you to substitute it into what we call the difference quotient. And so sometimes this is a confusing topic for students. It takes them a little while to get the hang of it. So we're going to go over 3 examples today. And then of course, if you want additional example problems, we can do that as well. And I'll let you tackle the assignment after you look at these. So this is what I mean by that. We want to take the x plus h. It's the same thing as what's written up here. Hold on one second. Let's make sure this autofocus isn't throwing us off here. There we go. So this is the same thing as this right here. It's just rewritten, but this is how you'll typically see it in directions. Well, let's go ahead and write this out. The first thing we need here is to find out what is the f of x plus h. Now, some students will just throw a plus h on the end here. You don't want to do that, okay? Follow the directions that I have for taking the composition of functions, which means we are going to write out the f of x, and everywhere we see an x, put a parentheses in there. And then plus 6 right there. So it's just like if I were taking the f of 3, I would write it out like this. Everywhere I saw an x, I would put a set of parentheses, and then I'd plug a 3 in there. But this time, instead of taking the f of 3, we're taking the f of x plus h. So everywhere I see a parentheses, that's what I'm going to substitute in. X plus h. And now from that, I can simplify it. So we're going to distribute the 2, and we get 2x plus 2h plus 6. This is the f of x plus h. So that's just one part. That is this part of the fraction right here. The rest of it is subtracting the f of x and then dividing by h. So I have the f of x plus h. I'm going to rewrite it just so we have room right here. We've got 2x plus 2h plus 6. And then I'm going to subtract from that. Get a different color here so we can separate everything. I'm going to subtract from that the f of x. So I want to say minus, and the f of x is 2x plus 6. Make sure that you are subtracting the whole thing there. So that negative right here is going to get distributed to the other two. And don't forget, all of this is over h. And so all we got left in this problem is to do some algebra and simplify it, okay? So from here, I'm going to distribute the negative, combine my like terms, cancel out anything I can, and then you're done. That's all you've got to do. But I know that some students have a hard time getting from here, the directions right up here, to this fraction right there. So let me recap it one more time. Basically, if you want an overview, what we're looking at here is this section is the f of x plus h. This section is the f of x. I'm subtracting the 2. And then I'm going to divide by h, okay? So that's how we set it up, but we still need to finish this problem. So I'm going to distribute that negative. And because it's getting messy, I'm going to write it all over one more time down below, but this time I'm just going to go ahead and write it in the same color. So we've got 2x plus 2h plus 6. And then we distribute that negative. We're going to get minus 2x minus 6. And then this is all over h. Well, what can be combined here? Well, we've got a positive 2x and a negative 2x, so they will add up to 0. We got a positive 6 and a negative 6, so those two add up to 0. And what I'm left with is 2h over h. Just this 2h right here over this h. And notice with that, the h over h just becomes 2, because h divided by h is 1, right? And this is all assuming in all of this, every time we do the difference quotient, we're assuming that h is not 0. So we get 2 here. That's what all of this simplifies to. In this case, it's simplified to a nice number. No variables added in there. It won't always do that. So if you get something that's got h's and x's in it, don't worry. It doesn't mean you did it wrong. But in this case, it did simplify to that. Let's look at another example here. So this one says, if the f of x is equal to x squared plus 1, find the f of x plus h minus the f of x over h, or the difference quotient there. Pause the video, give that one a try. So it's always this same thing here when we're talking about the difference quotient, but your function will change. All right, I take it that you've paused it and you're ready to see what I got here. Well, I'm going to first figure out what is the f of x plus h. So I'm going to write out the f function, and everywhere I see an x, I'm going to put a set of parentheses. And then in here, I'm going to substitute whatever's inside of this parentheses. In this case, it's the x plus h. Now, so x plus h is a binomial squared. So remember, whenever we have a binomial squared, you can FOIL it out if you want to. You can say x plus h times x plus h and multiply the thing out. I'm going to take the shortcut here and square the first term, square the last term, and then I'm going to multiply the two and double it. And if you forgot to do this middle step here, go back and watch my video, A Little Math Review, okay? Because that's where we cover why that happens in there. And then I'm going to throw that plus 1 right there. Don't forget the plus 1. So this is the f of x plus h. And remember, from that, we are going to subtract the f of x. And in this case, the f of x is x squared plus 1. And all of this is going to go over h, right? So take a look at this. This is how I'm color coding this thing. This is what's written in blue. That's the f of x plus h. That's what's written in blue right here. This part is in red. That's the f of x being subtracted from that. And then finally, it's all over h. And you might be frustrated at this point saying, why on earth are we doing this? Remember, it has its value in calculus, okay? But this is a good opportunity to start showing it to you so you can get ready for it. Because when you get to calculus, you want to be able to say, oh yeah, I remember doing that in pre-calc. Let's roll with it. Tell me, how does it help me with calculus? It will help you with calculus, so hang in there and just focus on completing these problems. So from there, I'm going to go ahead and say, all right, let's simplify this thing down. Distribute the negative over here, and we're going to get negative x squared minus 1. And I'm just going to bring down everything written in blue. So we got plus 1, h squared, 2xh, and x squared. And it's all over h. And let's simplify that thing. So let's see if there's anything we combine. We've got an x squared and a negative x squared that add up to 0. We've got a positive 1 and a negative 1 that add up to 0. And that leaves me with, don't forget our plus sign right here, that leaves me with 2xh plus h squared over h. Now, we've got some h's in common here, don't we? So you can look at it a couple different ways. Since each term in the top has an h, you can cancel out the h with the h on the bottom. That is an h. I know it looks a little bit like an n. That's an h. Some people like to look at it as like, hey, I got an h in common. Let's factor out that h. And now it makes it a little bit easier to see how those two are going to cancel each other out. I don't really care which way you do it. Just make sure if you're going to cancel out h's, each term up in the numerator better have an h with it, okay? Otherwise, you can't cancel them out. So in this case, you factor out an h. These two right here, h divided by h is 1. And we're left with this right here as our answer, 2x plus h. That's what's left over right here. Okay? I got one more example for you to try out. Let's look at this one right here. So this one looks like it could be an easy one. It says if the f of x is equal to x cubed, then we want to find the difference quotient there, but we're going to see that it can get pretty messy depending on how you go about solving the problem. So the first thing we're going to want to do is find out what is the f of x plus h, right? So I'm going to write out the f function, and everywhere I see an x, I'm going to put a set of parentheses, and then inside that parentheses, I'm going to put in x plus h. Now, what I've got here is x plus h cubed. And so we want to figure out what x plus h cubed is. There's a couple different ways that you could do this. You could write out x plus h times x plus h times x plus h. And I'm going to do something similar to that here in a moment. You could recognize and say, hey, this is a sum of, I'm cubing a function here, so there's a trick for that, right? Well, I'm going to bet most students don't have that memorized. I don't even always have it memorized because we just don't see it that often. I'm going to do something similar to this, but just to help myself out, I'm going to look at these two right here as x plus h squared, and I'm going to multiply x plus h times it. Notice this is to the power of 2, this is to the power of 1. If I multiply these two binomials here, or actually this is x plus h squared times x plus h, I'm going to get x plus h cubed. It's the same thing, I'm just splitting it up. And the reason why I do that is because I do have that one memorized. It comes pretty often to us. So I'm going to square the first term, square the last term, multiply the 2 and double it, I get 2xh. Once again, you could just FOIL it out here up top, but you should have this memorized because we're going to see it a bunch this year. And then I'm going to bring down this one x plus h right here. And remember, this is being multiplied. So I still have to multiply x plus h times that trinomial. And so how we're going to do that is just by distributing each term here. So I got to say x times x squared, that gives me x cubed. I'm going to say x times 2xh, that gives me 2x squared times h. I'm going to say x times h squared, that gives me xh squared. So I've now multiplied x throughout the whole thing. Now I've got to do the same thing with h. I'm going to say h times x squared, and that gives me, I'm going to write it off to the side here, it gives me h times x squared. And I'm just going to check, and normally, you know, it's okay to write it out right here and then combine them. I think it's easier to combine the like terms if I recognize, like, hey, I've already got an x squared times h. I'm going to write it right below it, and that will make combining like terms a lot easier. And that's a positive. And then I'm going to say, okay, h times 2xh gives me 2xh squared. That's this times this one right there. No, wait. Did I already do that one? I did not. Okay. And when I start talking, sometimes I lose my place. I haven't done that one yet. All right, so 2xh squared. And I'm going to put that one right below here, 2xh squared. And then lastly, I'm going to do h times h squared, and that gives me h cubed. And there's nobody to go with. I'm just going to write them right here. So what's written in red is x being distributed times that trinomial, and what's written in green is the h being distributed. Now I'm just going to go ahead and add these up, and I will get my f of x plus h. So x cubed didn't have a buddy. He just comes right on down. 2x squared h plus x squared h gives me 3 of them. Remember, it's like having a 1 right here. So I get 3x squared h. These two add up to 3 as well, so I get 3xh squared. And then lastly, we get h cubed right here in the end. So like I said, that's just the f of x plus h. And so I said, although it looked very tame in the beginning, it gets to be pretty complicated. It's not that it's hard, it's just that you have to be very careful. Even I was like, did I already do that one? So sometimes you're going to feel like that. Just make sure that you're drawing these lines and you're keeping up. You know, that's why I like to add them up like this, where I write one row and then match them up. It makes things a lot easier, and less likely for you to make a silly mistake, okay? Now, what's written in blue here is just this right here. Remember, it's just this portion of the difference quotient. We still have to subtract the f of x from it and then divide by h. So to subtract the f of x from this mess, what I'm going to do is just say, okay, the f of x in this case is just x cubed. So I'm just subtracting x cubed from what's written in blue, and I'm just going to line it up right here. This is my f of x, it equals x cubed, and notice he pairs up with the x cubed right there. And we are subtracting it. And so when I subtract it, these will cancel out, and I'm left with 3x squared h plus 3x h squared plus h cubed. And so what we have here is, I'll try to write this out so it's a little more systematic. We have the f of x plus h right here. We have the f of x right here. It's, we're saying the f of x plus h minus the f of x. And then lastly, in the difference quotient, what do we got to do? We got to divide everything by h. In this case, we do have an h in common with each term. So when I divide everything by h, well, it's going to cancel out some things, right? It cancels out the h in each term. Oh, this one's still going to have an h there, and this one's going to become a 2. So that becomes a 1, that becomes a 2, and that cancels. So basically, we're going to get 3x squared plus, this was h squared, so when you divide it by h, you're going to get 3xh. And this was h cubed, so when you divide it by h, you get h squared. And this is our answer. Now, just make sure nothing else can be combined here. I don't see anything else. If it helps you, if you're wondering, like, how did he go from here to here? If that confused you, the canceling out, let me just kind of show you what it looks like when you do what we said earlier and just kind of factor out that h. So I'll rewrite it. You had, let's see, 3x squared h plus 3x h squared plus h cubed. And we're going to divide that by h. That's the f of x plus h minus the f of x. If you factor out an h that's in common, what do you get? Well, you get h times 3x squared plus 3xh plus h squared. And then, so that's the same thing still as the f of x plus h minus the f of x. That's when we're going to divide it by h, and those cancel. Here's your answer right here. That's the same thing I did right there. You can do it either way. I don't care which way. But like I said on the other problem, make sure that each term has an h, because it has to work out like this, that you could factor out the h and then cancel the h's. If it's something like this, 3h plus 5 over h, you can't cancel out the h's in a situation like that. Both terms have to have an h term there. I don't care if it's h squared, h cubed, they have to have a common factor of h. In this case, we cannot cancel because there is an h missing, and so then we just simply say, boom, there's our answer, nothing simplifies. Okay? Try those problems out. I'm going to assign you a few difference quotient problems, not many, because they do take a little while to do. But give them a try. Let me know how you feel about them, and I will see you next time. Thanks for watching.